So to start this off, we're going to talk about even and odd functions. So you probably didn't see this back in Algebra 2, but we are going to look at it now. This does kind of relate to polynomial functions and the directions in which they're graphed. So I'm going to try to connect this as best I can. Okay, so for even functions, I'm going to go through the definitions first, and then we'll actually look at the graphs and the equations for it. So for an even function, a function is even if it meets this notation. F of negative x equals f of x. So f of negative x equals f of x. And that's for all x's in the domain of f. So the right side of your equation of an even function does not change if x is replaced with negative x. Right now, it's not making sense, but it'll make sense before the end of the period. Even functions are symmetric with respect to the y-axis. So that means that if you were to fold the graph on the x-axis, it would line up perfectly. Another way that you can determine if something is symmetric to the x-axis is if you have a coordinate, x and y, and it doesn't matter what the coordinate is, you're going to notice that when it's symmetric to the x-axis, the x values are negative and the y values stay the same. So this top part is if you're looking at it algebraically. That's probably spelled wrong, but it's okay. And then this is specifically for graphs. So there's two different types we're talking about. Graphically, which is down here, and algebraically, which is up at the top. I'm going to talk about both of these before we leave. And then for odd functions, a function is odd if we meet this notation f of negative x equals negative f of x. And again, this up here at the top is algebraically. So if we can meet this notation, f of negative x equals negative f of x, then we know that the function is odd. That means that for every term on the right side of your equation, it's going to change if x is replaced with a negative x. And then if a function is odd, again, this is graphically, down at the bottom, this is graphically. An odd function is symmetric with respect to the origin. That means if you were to literally flip the image, so the graph, upside down, it will appear the exact same. For me, at least for origin, this is just for me, but for me, whenever you're trying to determine if it's odd, it's a little difficult because you have to know exactly what the graph looks like in its non-upside down position. So I try to confirm it two ways. I'll flip it upside down to kind of do a visual confirmation, and then I'll do a mathematical one where I look at the coordinates. So again, we're going to look at x and y, which is any coordinate. And when you're looking to see if it's odd, the x and the y are both going to become negative. So that's a really good way to see if it is an odd function, is if your x and y values turn into negatives. And if these x and y's that you picked were originally negative, they would both turn into what if they were for odd? Positive. They would switch signs pretty much. So with that in mind, these are the two differences between even and odd. If we cannot classify a function as even or odd, then we're just going to call it neither or neither, however you pronounce that. So let's look at the graphs below. So for graph number 1, I'm going to first do even, then odd, then neither. And we're going to do that for all of them. I'm always going to check to see if it's even first. So to check to see if it's even, I'm first going to fold this along the y-axis to show you what that looks like. So for me, at least, I'm going to rip off that first page. You don't have to, but I'm literally going to fold this right along the y-axis. And when I fold it, I want to see if I was going to reflect this across the y-axis, it should be symmetric. So it should land right on top of the other side. And if I look at this graph, it's a little hard to tell just from where it is. And I don't know if you could see it on my document camera, but it looks like this part of the graph is up here. This part of the graph is down here. So it doesn't look like it literally reflects right on top of itself. What I'm going to do to further confirm that is I'm going to look at the coordinates. So I'm going to pick two coordinates and I'm going to see what the negative x comma y looks like. If the negative x and y is on this line, then it means that it's going to be even. So let's pick 2 points on here. So let me see. We'll pick 2 and 5. And I do apologize in advance for how the graph looks because it should be a lot nicer. But I'll use 2, 5, and I'll also use 3 and looks like 9. So 3, 9. It's a very rough estimate on what those points are. And in order to see if it's even, I'm going to make the x value negative, and the y value is going to stay positive. All I want to do is see if these points that I've just written are on this black graph. So at -2, +5, that's right here. Is this pink dot on the black graph? No, it's not. So that means right off the bat, it's not even. If those points that we just rewrite are not on the graph, that means that it's not even. Let's check to see if it's odd. So odd means if you read the graphical part, if you flip the image upside down, then it'll appear the exact same. Okay, so let's check to see if it's odd. For me, it's a little difficult to see if I was to flip this upside down. I mean, it looks like the exact same graph. It's still slanted to the right-hand side. The way I double check it is to see, okay, let's look at the coordinates. If I pick the same coordinates, both of the x's and y's, if they're negative, they should both land on this graph. So let's see. If I have 2, 5, and 3, 9, they should both land when they're negative on this graph. So -2, -5, -3, -9. So -2, -5 is right here. Is that blue dot on the graph? No, so that means that it's not odd. If it's not even and it's not odd, what is it? It's neither. Let's do the same thing for example 2. First thing we want to check is to see if it's even. Always start with checking if it's even. So to see if it's even, I'm going to fold this along the y-axis. And I want to check to see if it pretty much is symmetric. Well, it actually looks like it just from here. If I was to fold it again right down the middle, this looks like it's lining right up, but let me double check. The way that I double check, I'm thinking that it's even. I'm still going to pick 2 points. So let's pick 1, 2. And let's pick 2, 3. I usually will pick points on the positive side of my graph because it's easier to make those negative. Okay, so if I was to make it to see if it's even, only make the x's negative. So -1, 2, and then -2, 3. Looking on the right side of this graph, or the left side, excuse me, I'm going to go over 1, up 2. Okay, that actually lands right here. And then -2, 3, that's over 2, up 3. That also lands on the graph. What does that mean? It is even. Even, you're going to see those points directly reflect over on the other side. So it's almost looking like the absolute value parent function. It's very similar to it. It's a little up, but it's the exact same thing. Notice that this side is going to be symmetric to the other. Let's look at one more problem before you try a couple on your own. Let's look at number 4. So the first thing you always want to check first is to see if it's even. Okay, even means if I was to fold this along the y-axis, which there's still a crease. Okay, I'm not seeing this thing line up beautifully. It looks like this side's going up and this side's going down just by reflecting it. So let's confirm that with my coordinates. So I'm going to pick some points, and I do apologize again because these points are not the most beautiful. I'm going to use 2, 2, which is kind of that point. We're going to say that that one's 2, 2. And then the other point I want to use, we'll say that this is about 3, 8. I think that's about 3, 8. On tests and quizzes, your graph will be a lot nicer. Okay, so first let's check if it's even. Okay, even means I'll make -2, +2, -3, +8. Okay, well, I can tell right now, -2, +2 is not going to work because that should be up here in the second quadrant. So right off the bat, this is not even. Let's check to see if this is odd. So to check to see if it's odd, I'm going to use the same points, 2, 2, and 3, 8. And for odd, we haven't done that in a while, but for odd, we're going to make both of the x's and y's negative. We're pretty much going to switch their signs. So at -2, -2, it looks like it lands right on top. And at -3, -8, we'll say is right here. That also looks like it's on top. So this graph should be odd. Right now, I want you guys to try the same thing, but for the other graphs. So I will give you some points that you can use for this, just because I know some of them are a little difficult to see. We can use 1, -5. So this one is 1, -5. I'm going to write them out. And then we can also use 2, and it looks like -8. And then for this graph, I mean, we can technically use the origin. There's nothing wrong with using it. And then for 1, say 6. And then for this graph, it's a little up. We can use 4, 3. That might be the only good point we can use. Yeah, let's just use those. So the points that I have listed, those are the points I want you guys to use. All right, so go ahead and get started. Figure out what those are going to look like. Are they even, odd, or neither? Some of you guys might not need to graph these out or look at the graph or look at the coordinates. Some of y'all can look at the graph itself and determine if it's even, odd, or neither, but I'm showing you guys how to do some work with it. All right, I'm gonna give you guys about 2 minutes. Go. So let's look at the answers you got for examples 3, 5, and 6. So for number 3, you guys tell me, was this even, odd, or neither?
Even.
This one was even. What about number 5? Odd. This one was odd. And for number 6? Neither. Yes, sir. You would still get 0, 0, but what about 1, 6? So that's why I always try to pick more than 1 point. For this question, I really could only find 1 usable point, but that's why usually I have you guys pick 2 or more, because it can't be even and it can't be odd at the same time. It's either even or odd. So yeah, so for this one, for even, for instance, it would be 0, 0, which pretty much is the same point here. But for even, this would be at -1, 6, at -1, +6. That's all the way up here. So that's why that question wouldn't work. So this one, that's why that one's not even. Is that okay? For odd, though, when you make both of them negative, 0, 0 is going to be the exact same, but -1, -6 is down here now. So that one would work. Is that okay? All right. So for these graphs, it's a little difficult to see. I probably should have like stretched them out a little bit so that we could actually see nice intersections. But for these, it's kind of ugly, especially for this last question. So even for these, you technically could have even picked, like for the original ones that you were comparing for X and Y, you could have picked -1, +6 and +1, +6. You could have used that as well. I usually try to pick them positive first just because it's easier to make them negative. So it's up to you though. Is that okay? Mhm. So for this one, like, let's say originally, so we didn't have any of that. Let me get a sticky. Let's say when I first told you guys to pick some points, let's say you picked -1, -6, because that's actually a point, and the origin again. If you were doing even for this, well, -x means you're pretty much going to change the negative sign to a positive. You're going to do the opposite sign. So this one would become +1 and then -6, which actually is on your graph. +1 or negative, excuse me, +1 and then -6. That's not on the side. Hold on, let me see. -1, -6, right? And then when we do it for even, we make this negative, so negative and negative is positive, and then -6. Oh, duh, because that's not even. Duh, that's why. So because of this point right here, it's not even. Is that okay? And then for the odd one, when you change for odd, -1, goodness gracious, -1, -6. For odd, let me go back up here. You would make both of them negative. Whoops. Both of them negative. Well, if they're already both negative, what sign are you going to turn it into? Positive for both. That point is on your graph. +1, +6 is right here. So that one would work. Is that okay? All right, good. Okay, so that's all the graphical ones. So all the ones that we're talking about graphically, that was this middle section down here. What we're going to do on the back side of this page is talk about it algebraically. So hopefully you feel okay with how to do it from a graph. Now let's talk about how to do it from an equation. Okay, so when you're looking at an equation, to verify algebraically that a function is even, odd, or neither, you must prove the following. For even functions, you must prove that no signs change. You also want to prove a way to kind of show that none of your signs change. You want to prove that f of -x will equal f of x. This is the statement you're going to prove. F of -x equals x, and that's going to show you that it's even. If you wanted to prove that something is odd, you want to see that all of your signs change. And the way that we're going to prove that is by finding f of -x equals -f of x. So f of -x equals -f of x. That's what we're going to prove. So it seems kind of confusing, like, wait, I don't get it. How are we going to prove these two things for even and odd? Well, the way that we're going to do that is by doing the following that I have at the bottom. So I'm going to actually take each of these statements for even and odd. I'm going to check first to see if it's even, and then I'll see if it's not even, maybe it's going to be odd. Whenever you're trying to check these, you want to make sure you know how to appropriately simplify your function notation. So I'm going to quickly review the different types of function notation, and then we're going to take these rules to see if they apply to the problems down here. So for f of x is always repeating the original function. So it's literally the exact same thing. So this is f of x, this is your function of x. For f of -x, what would you plug in? Say it again. A -x. Whatever's in this parentheses is what you're plugging in for every x, and then you're going to simplify. So for this f of x function, let's find f of -x. Well, the way you would do that, both of these x's, you would replace them. You would replace them with this -x. -x here, -x here. -x squared. When you have a negative that's being squared or raised to an even power, what happens? It turns positive. So -x or -x squared is just going to turn into x squared. And then 3 times negative x is negative 3x plus 5. That's how you would simplify something like this when you're doing f of negative x. What does negative f of x mean? Say it again. Everything's negative. So every sign that you have changes. So you're going to change every sign that you see in f of x. So if you start with the positive, you're going to change it to negative. If you start with the negative, it's going to change to positive. So for negative f of x, we're going to make this negative parentheses, x squared plus 3x plus 5. And all I'm going to do is I'm going to change every single sign that I see. So I'm pretty much just distributing. So we're going to make this negative x squared minus 3x minus 5. So I'm not saying that these are even or odd. I'm just showing you guys, I'm refreshing your memory on what it means to do f of negative x inside the parentheses and negative f of x where it's outside of your parentheses. So let's look at question number 1. Whenever you're checking these algebraically, always check the even one first. Always check even first. So for even, I want to check to see if f of negative x is going to equal f of x. I want to see if these two expressions are going to be the same. So the way that I check that for even, f of x is here. So I already know what f of x is. I want to see what f of negative x is. So for f of negative x, I'm going to take this x and replace it with the negative x. Now all I need to do is simplify. So to simplify, negative x to the third power, does that become positive or negative? Negative. And then negative times negative is going to give me a positive 6x. So the way that you tell that it's even, you need to see, is f of negative x equal to f of x? Are these the same? Yes or no? No, these are not the same. The negative x cubed is here, positive 6x is here. They're completely different. So for this question, it's not even. Since it's not even, we now need to check to see if it's odd. Before we check to see if it's odd, have I lost anybody with what I just did? You're just checking to confirm, is this statement true to prove that it's even? Yes, ma'am. Say it again. This one? No, okay, so these two, I'm not talking, I said this earlier. These I'm not trying to confirm if they're even or odd. I'm just showing you how to do basic function notation. This is just a review of basic function notation. There's no even or odd up here. Is that okay? All right, so down here, I now need to determine, is this odd? Okay, so we know it's not even. This statement was not true. Let's see if odd is true. If f of negative x is equal to negative f of x. Let's see if that's going to work. Have I already done f of negative x? Gabriel, where are you seeing f of negative x? Say it again. Where's right here? This? Yeah, the stuff that we just did. That's f of negative x. Okay, I want to see if this is going to match up with this statement. So negative f of x. So we're going to take for negative f of x, negative function of x. Function of x is this guy here. So we're going to take negative x cubed minus 6x. Oops, not negative, that's positive. So positive x cubed minus 6x. What did I say you're supposed to do with that negative symbol? Distribute. So we're going to distribute this negative to both of these terms. So we're going to have negative x cubed plus 6x. I need to know, is it odd? Does negative or f of negative x match negative f of x? Yes, these do match. So that means that this function is odd. Odd means that f of negative x equals negative f of x. This statement is true. That's what makes it odd. So all we're doing, and I'll repeat this again, all we're doing is we're trying to prove one of these two statements. That's all we're trying to prove. Either this whole statement or this whole statement. That's it. So if you think you know what you're doing, go ahead and try number 2. I am going to start it with you, but for some of you guys, you might be able to get it right away. For question 2, we're checking first. Always check first to see if it's even. Always check that first. So we're going to see even first. is f of negative x. Whoops, let me replace that. This is an f of x function. For number 2, this is a g of x. I'm just going to replace that f with the g. So g of negative x should equal g of x. I'm not changing any values. I'm just making it easier for you to see. Okay, so for this being even, g of x is here. All right, so I already have that one done. I need to do g of negative x. So for g of negative x, I'm going to substitute in a parentheses for every x that I see. And I'm going to substitute in this negative x to both of the parentheses. When you're raising a negative x to an even exponent, does it come out as positive or negative? Positive. So negative x to the 4th power, that's just x to the 4th power. I'm going to recopy the negative 2. Negative x squared, all of this is going to turn positive. So it's just going to become positive x squared. So to see if it's even, does this statement match up with the original? Yes, it does. So that means that this is even. When it's even, you've just shown that g of negative x, which is this guy here that we just found, is equal to g of x. Remember, for even and odd, you were just trying to prove the statement that I highlighted at the top in yellow. That's all you're trying to do. Are we okay? Enya, you okay? All right, good. Yes, sir. So that's what I always try to avoid you guys looking at with seeing, okay, well, if it's even, it has to match the original. If it's odd, it has to match the even. That whole statement doesn't make a lot of sense to some people. So I do see what you're saying. Yes, you do need to check to see if what you did to prove that it's even matches the odd statement that you have. So I just keep it simple and say you need to prove these to prove that it's even. You need to prove these to prove that it's odd. Very simple. So let's do one more question together. And then after that's done, I'll have you guys try a few. So I'm still proving on this page, these two, hopefully one of these two. So for the first one, let's determine if it's even. So to see if it's even, this is h of x now. So I'm going to do h of negative x should equal h of x. Almost thought that was an f. Let's see if this statement that I just wrote out in green is true. Okay, so h of x is here. I don't need to worry about that, but h of negative x, I do need to simplify. So we're going to make this negative, oh, not negative, x squared plus 2x plus 1. In both of those parentheses, I'm going to substitute a negative x. You guys told me a negative being squared turns into positive. 2 times negative x is just negative 2x plus 1. Does h of negative x match h of x? Yes or no? No. Okay, so that means that it's not even. Let's check if it's odd. So we're trying to prove here h of negative x is equal to negative h of x. So we're trying to prove if this statement here is going to match up with negative h of x. So to prove that, I'm going to take negative h of x. And the whole h of x function, I'm going to put in the parentheses, x squared plus 2x plus 1. And like we said earlier, we're just distributing this. So negative x squared minus 2x minus 1. To determine if it's odd, I need to see if h of negative x matches negative h of x. Do these match? They do? No, they don't. This is negative and this is negative. These two aren't negative in green. So unfortunately, this is not odd. If it's not even and it's not odd, what is it? Right now, you guys do numbers 4, 5, and 6. Do the same thing I just did. Check first to see if it's even. If it's not even, check if it's odd. If it's not odd, it's neither. It cannot be even and odd. That doesn't exist. I'll give you guys a quick 2 or 3 minutes to get that done. For question 4, is this even, odd, or neither? Even, this is even. Do I need to go through this one? If you have a question, guys, I can't read minds. If I could, I wouldn't be a teacher. So if you have a question, tell me. This is even. What about number 5? This one is odd. Do I need to go through this one? You want me to go through it, Sabria? No? You okay with it? No. Okay. All right, just making sure. And then last one, number 6. This one's neither or neither. Do I need to go through any of those 3 that I just talked about? Okay, that's it. That's all I have in me. The entire backside of this page is extra practice for you guys. They're a little more fun, a little more challenging, so definitely try them before your tests and quizzes.